right, looks like we're okay now. Welcome everybody, and here we go. Welcome everybody to our lab's open office hour on Friday, right at 1 p.m. Yep, that's today. That's our time, and so welcome. Hope everybody's having a good Friday. We are joined today. Welcome everybody to our
Is that
lab's
me?
open office hour
Oh, that's
on
me.
Friday, right at 1 p.m.
I
Yep,
have
that's
the stream
and,
unmuted.
So welcome. There we go. You'd think I'd done this before, right? Okay, so welcome everybody once again. This week we have William, our photogrammetry engineering CAD software expert from Labs, and I suppose we'll start off like we normally do. William, just in case for those of the audience at home or wherever they may be, if they don't already know, give a little intro, introduce yourself, explain what it is you do, and all that good jazz.
Well, I've been here at Puget Systems for, I think it's going to be 15 years in a few months here.
Nice.
The last few of which have been in our labs department. So what we do up here is testing various software packages that are fairly popular and that a lot of our customers are using on different hardware configurations, mostly looking at CPU and video card performance, since that's usually the stuff that drives things, but occasionally also dipping into stuff like RAM usage or hard drive speed, things like that occasionally. SSD speed these days, honestly. And then we take that information that we gather and use it to write articles that we publish on our website so that the community at large can know what sort of specs to be looking for depending on what software they're running. And then we also utilize that to put together our recommended systems for our customers to purchase and for our consulting team to be able to use when advising people. And then occasionally we do things like this, Q&As and webinars and trainings and stuff as well.
Yeah. And that's kind of the point of the for these Friday shows is to kind of just break out a little bit of time, take a moment to kind of give an opportunity, one for you to showcase anything kind of cool and interesting that you might have stumbled across lately, and also for the folks at home or audience at least to maybe ask a few questions of their own, which actually I know I had one come across my view fairly recently, and it involves RAM speeds. With the introduction, we're starting to push AMD's been killing it lately. The Ryzen and Threadripper stuff has been really top notch.
Yeah.
And a question I know that we've covered in the past, but one that has come up a lot more often recently, is how come we only offer 2666 RAM speeds when AMD, Ryzen, and Threadripper are capable of supporting higher speeds?
Well, so that's at this point a little bit dependent on what's available. There's of course much higher memory speed stuff that's been on the market for years now, 3200, 3600, even higher. But what AMD's processors officially support depends on how many memory modules you're using and what density they are. So for most of the configurations, we would sell 2933 is the memory speed that is officially supported by AMD.
Okay.
However, it's hard to find 2933 megahertz memory that is on their QVL lists for motherboards and widely available and from reliable brands and all those things. You can find higher speed memories, but again, we don't like to push past manufacturer specs because that's a form of overclocking and it can lead to reduced stability and things like that. And there's not a huge performance benefit. Sometimes there's a few percent, but in our opinion, stability is more important than a little tiny bit of performance, because if you end up losing hours of work at some point because of a crash or a blue screen or something, you've wiped away all the benefit you would have ever gained from having that memory. So we're actually, it's not really our department up here in labs, but in a product qualification, they've been working on trying to find a reliable source of 2933 megahertz memory. And it gets tricky because you can use like the higher memory stuff and just downclock it, but then it looks kind of weird to be selling one thing and setting it at another speed. And a lot of times you have to go in and change a lot of stuff in the BIOS to get them running at the correct speed, which isn't really ideal, because then if the BIOS gets reset, suddenly you're not using the right memory speed and it can be a hassle for users. So what we're trying to do is find, as I understand it anyway, again, not my department, but we're trying to find memory modules that we can get that are reliable, that behave well with the Ryzen and Threadripper boards, and then that default to the correct speeds, or at least only have to be set to the right speed, and then all the other settings follow suit without having to go in and adjust a bunch of options.
Cool.
So I think they're making some progress on that,
Mm-hmm.
but it's being tricky. And it's all the more important now because not only is AMD supporting 2933, but the latest Intel processors are as well now. So
Oh, okay.
hopefully most of our line will be moving up to that as soon as we can reliably secure some.
Oh, cool. Okay, cool. Thank you for that. I knew there was some. I knew part of that, the like how many memory modules you're actually using and their density, but then, of course, there's always availability and things like that that tend to go into those as well. So
Yeah.
that's pretty cool. Thank you.
Yeah, no problem.
Let's see. Oh yeah, there's talk about tighter timings with lower frequency and things like that. So okay, yeah. So since we're on that with AMD and such, I feel like I kind of skim a lot of the articles. I don't get an opportunity to dive into all of the meaty stuff, but especially it seems for your particular expertise, your slice of the pie here, AMD has had a massive effect on performance in
Definitely.
those sorts of like photogrammetry and especially like Pix4D.
Yeah, Pix4D, it's fantastic. I also cover, at least at the moment, a lot of rendering applications. So V-Ray, for example, on the
Right.
CPU side, it does really well. I think some of that's going to be moving over to Kelly, maybe eventually. I'm not entirely sure, but he's
Okay.
doing a lot of the more 3D design and animation stuff, which rendering ties in with nicely. But yeah, there's really any of the programs that tend to benefit from a lot of cores. Yeah, AMD's been killing it, like you said. Um, it's not uncommon for like the top end Ryzen, which is like a $750 processor,
Mm-hmm.
to beat all of Intel's stuff, even up into the over $1,000 range, all of their Core and Core X line.
Yeah.
And then they just don't even have anything that can compete with Threadripper. So
and that's a kind of an interesting point too, because like oftentimes you'd see Xeon, right, would be the like higher core count Intel offering.
yeah, for a long time, yeah.
And so to see now that even what would be considered more of a consumer chip is just kind of they're kind of kicking butt. It's
Yeah,
pretty cool.
it is very impressive.
Yeah. Um, not to get kind of maybe esoteric, but why do you think that is? Like, is Intel falling behind? Are
Um,
they the giant that's just too slow moving, or?
well, so I do think there's a couple factors probably. This reminds me a lot of what happened about 20 years ago. I don't remember exactly what year, but there were a few years in like early 2000s, maybe even starting in the late 90s, where AMD was ahead as well. They were the first ones to 1 gigahertz, things like that. First to do
True,
I
that.
believe they were first to do a dual core CPU. A few of those things, if I remember right. It's been a long time. I used to use AMD processors back then,
Same.
and I'm glad that they're back now. Um, but I think part of it is, yeah, bigger companies can get more set in their ways. They get used to being in the lead and maybe not fighting for it as hard. Um, but there's also something I think to be said for, on the other side, the motivation of smaller companies. If they want to have a chance, they have to do something new, different, unique, better, or why would anyone buy from them?
Sure.
So it's a combination of things. I think Intel, I know also, at least it seems like, has been stuck on the same manufacturing process for a few generations now, and
Right.
I don't think that was their intent. So I'm assuming that there must be some technical hurdles that they're facing. So once they get those dealt with, who knows? Maybe we'll see a big giant leap from Intel as well, which would be great. That's kind of what happened back when AMD got in the lead a couple decades ago. Was, yeah, it took a couple years for Intel to catch up, but then when they released the Core series, the early, like before any of this i5, i7 stuff, was just Core 2 Duo, I think, and Core 2
stuff.
Quad.
Right.
Yeah, that generation took over from the performance lead from AMD again. So, competition is good. Sometimes one company is in the lead, sometimes the other, sometimes they're comparable. But yeah, it's a good thing. It would be far worse if only Intel or only AMD existed.
Oh, absolutely. Yeah. It is interesting to me to see that. AMD has what seems to be a manufacturing process with the 7 nanometer lithography, right? It's a lithography thing.
Yeah, I
And
don't know all
it's
the technical
curious.
terms.
It's curious that Intel, being the Goliath that they are, that they can't seem to figure it out, and it's
Yeah,
just kind of
I'm
a
not entirely
weird.
sure. I know when you're dealing with stuff, I mean, these things are measured in nanometers, which is absurdly small, almost
Yeah.
unimaginably small for normal humans. So there's a lot of weird hurdles, like you said, technical stuff to get through when you're dealing with that. And something can look good on paper, but then you actually try it and it doesn't necessarily always work out. Or one thing I know with chip stuff is you might have something that works, but the yields are really bad. So only a small part of the
Oh.
silicon actually ends up being viable and things
Hmm.
like that. And you can't really go ahead with a manufacturing process if you're only getting 10% of the product you're making to actually work. It's just not going to be cost effective. So there's
Sure.
I'm sure there's a lot of weird stuff like that going on. I'm no expert in chip design by any means, but
I,
I have been monitoring the industry for 25 years. So
so I'm curious, what of all of the softwares that you test and kind of have your fingers into, which one is the most fun for you to play around in?
oh, that's an interesting question. Um, I don't know. I don't actually end up spending a whole lot of time playing in the software. When you're developing a benchmark or something, you do. But once I've got those set up, it tends to be kind of just leave it alone for the most part. Photogrammetry stuff is pretty cool. Just the way it works is neat, and getting watching how that comes together from just a bunch of different still images to a 3D model. Um, and that's probably the one that I end up playing with the most.
Hmm.
The engineering and architecture software and stuff that I test, honestly, that sort of stuff is so beyond me in terms of I'm not an engineer, I'm not an architect, so I can't appreciate any of that stuff that's going on. But I do take photos,
Sure.
and it's pretty cool to be able to see just a bunch of still images you take of something turned into something more than that. So I can
Yeah.
appreciate that more, I think, maybe, and it's a little closer to home. Yeah.
I remember when we first started investigating into photograph. I think it was when we first started, anyway. I happened to be a test subject, and it took a bunch of photographs of me standing in a warehouse,
Yes, I
and
remember
we
that.
and we 3D printed a me standing there. And now, but even and as personally as fun as that was for me personally, but it was so the I guess the science that goes into it, the technological achievement that is taking all of these, like you said, still frames and building like a 3D mesh cloud, all this point cloud, I think is the
Yeah.
term, and then being able to turn that into a 3D model and then slice it out and all that stuff. It was just mind blowing.
Yeah, it's definitely crazy. I again, not one who can understand the software side of what all they're doing behind the scenes, but it's very neat to see in action, and it's interesting to see how different photogrammetry programs that are trying to accomplish the same thing also can behave wildly differently in terms of what system resources they're utilizing. Some are very well threaded, like Pix4D does pretty well with that. Some aren't nearly as well threaded, need just fewer cores but higher clock speed. And that's actually one of the things I was doing testing on recently is some of those that don't benefit from as many cores. If you have a moderate to higher core count processor, actually it turns out that turning off hyper-threading or simultaneous multi-threading, AMD's version of the same technology, improves performance. So basically telling the
Huh.
the system you have fewer cores and not letting it sort of double up work on cores like those features normally do actually improves performance. In some of them, in Pix4D, it slows things down because it can use those cores. But in Metashape and to a lesser degree in Reality Capture, which those are the three that we test,
Right.
um, in those programs, if you had more than around 12 cores, it actually helped to turn those features off. So
Hmm.
go figure.
Yeah, I noticed that in one of your recent articles. That was kind of an interesting the mixed bag there.
Yeah.
Yeah. So we have a question from the audience,
Oh.
from Desmusant10 on Twitch. He's asking, talking about RAM speed holding to 2933. What is the opinion on PCIe 4? Even knowing that it will take time for programs to be optimized for it, when would building in the near future focus on the PCIe 4 or stick with PCIe 3?
Well, so PCI Express 4 um, is basically just going to be doubling of bandwidth from PCI Express 3, and that's PCI Express is used primarily for communicating with video cards and other expansion devices too, but most people use video cards. It's rare that, you know, you can get like network cards or RAID controllers, things like that too, but those aren't very common. And then the other interesting place it's used these days is also connecting to higher speed SSDs. So anything that uses like M.2 or directly into a PCI Express slot, that's also using PCI Express. And for video cards, in most of the things I've seen, there tends not to be a huge difference already between PCI Express X8 and X16, so that the lane counts there, which is a doubling of performance there from X8 to X16, but it's rare to see more than a couple percent performance difference, again, at least in my experience in the stuff I test there. So I don't expect 3 to 4 to be a huge jump in performance either.
Okay.
You're just giving it more bandwidth for the system to communicate with the device, basically.
Okay.
And I mean, if we're already at a point where current PCI Express 3 doesn't seem to be limited, now, again, there's probably applications where it is, just not the stuff that I test.
Sure.
So I'm not super interested in that. And then you also need both the system and the video card to support it. And right now, yeah, the latest AMD stuff does support PCI Express 4, but I don't know of any video cards yet that do. I maybe some of the latest AMD stuff, I'm not sure, but Nvidia at least doesn't yet. I have no idea what's coming in the RTX 3000 series whenever that comes out. But at the moment anyway, getting a board with it doesn't really matter from that perspective. Now on the other side, the SSD side, there are SSDs now that are starting to come out that support it. But
yeah,
again,
I did think that was kind of interesting. Intel came out with a PCIe SSD that is compatible with the PCIe 4.
And they don't even have a PCI Express 4.
AMD is the only one that supports PCIe 4 right now. So
yeah, it's kind of funny.
It's a weird miscommunication, I think, amongst departments there.
Well, I think, I mean, they're just probably pushing ahead. Like, I'm sure the SSD folks there at Intel are separated enough from the motherboard and CPU folks. They're just pushing ahead with the technology when they can. But even there, again, unless you're doing something really, really niche, you can get drives on PCI Express 3 that'll do 3.5 gigabytes per second.
Right.
I mean, none of my applications that I'm testing are sensitive to the difference between that and maybe the 5 or 6 gigabytes a second that you might get on some of these new drives, because that's just so much data bandwidth already. I'm sure there are niche cases where it's helpful.
Right.
But at least for most folks, and again, folks doing the stuff that I test, it really doesn't matter. But with that said, I mean, it doesn't hurt either. So,
right. I feel like it's kind of almost like a leapfrog sort of deal. It's like now it may not be necessary because like we're probably not even maxing out what we have now. But now that there is the possibility, they have the opportunity. I think it gives it just kind of provides a bit more of a flexibility for the future.
Yeah, and there's it happens with USB as well. For example, like, I mean, again, the vast majority of things that most folks are doing on USB, you're not going to be able to tell the difference between 3.0, 3.1, 3.2. I think they even call them all 3.2 now with different generation names. They've retconned the naming on USB a few times. But again, I mean, if you're talking about plugging in a USB thumb drive and copying over some photos, odds are that either the drive itself internally, regardless of what speed it can connect at, the memory internally probably isn't fast enough, or you're not copying enough for it really to make a huge difference whether you're getting 500 megabytes a second or 1 gig a second or what. It's anything these days. It's gotten to the point, again, especially outside of like CPU and video cards themselves, there you can still see performance differences. So many of the rest of these things, memory speeds, bandwidth between devices through PCI Express or USB, are all so fast that it really doesn't matter all that much. I'd much rather have a high quality device that used a slightly slower connection than a bleeding edge device, but that isn't as reliable or has some other weird thing, overheats or something stupid like that. So that's my perspective on it.
Yeah. So we have another question from the audience. This one is from Eric. He says, not sure if you mentioned it already, but what are some of the more interesting uses of photogrammetry right now, and what are the most common hardware configurations for those uses?
Well, so the hardware configurations, like I said, I mentioned a little bit that it varies a lot depending on what software you're using. So
Mm-hmm.
the hardware configuration that's best for Metashape, for example, is not the same that would be the best for Pix4D and vice versa. So you want to look at the hardware configuration based on the software you're using more than the use case of what you're doing with the software.
Okay.
But you need, I could rattle off a bunch of specs, but it's probably just as easy to just go look at our website. If you go to PugetSystems.com and look at the publications section, articles, you can even narrow down by specific application or just scroll through recent stuff and see. Or you can go to our recommended systems if you want to see what we sell. But as far as use cases, I know one of the things Pix4D at least is recently doing, and I think other companies have done it with their software as well, but is kind of focus on like emergency response and crime scene stuff. So like I think they even released a special version for this that has a more limited feature set, but is designed to be run quickly in the field. Where, they're able to take a bunch of pictures of like an accident, for example, car accident, and get that done so they can reconstruct it later, and then you can clear out the scene more quickly instead of having to leave a car accident in place for hours while detectives are coming out and investigating things and preventing traffic the whole time, blocking traffic. So you can get things more quickly done that way, or
That's
you can
cool.
get the results sent off to like somebody off site to do an analysis on or whatnot. I've actually got some friends who are in the a friend in the state patrol who does investigation stuff like that. I should ask him one of these days if he uses anything like that the next time I see him. But yeah, some interesting stuff like that. Which again, I haven't played with that version specifically, but it's doing the same sort of stuff with photogrammetry, and they can use it, like I said, also for emergency response stuff. If you've got satellite data or aerial photography of a lot of the world nowadays, but it's usually weeks to months, maybe years old, and being able to quickly come out with a drone and just do a quick survey and make a new map of a area that's changed because there was a flood or different things like that can be really helpful. So that sort of stuff, like the emergency response stuff, is pretty cool.
Pretty cool. Like, I mean, so from what I know of how photogrammetry works, you could essentially just very quickly take a whole bunch of pictures of the scene, bring it back home, and recreate the crime scene or whatnot.
Yeah.
That's really neat. Wow. And then, of course, you could then go and take that and put it into something like Unity or whatnot, and then potentially be able to like actually walk around.
Yeah, it actually reminds me. There's a scene in Iron Man 3, I think it was, that basically is that it's more advanced than anything even that we have now because it's got holograms and it's a sci-fi movie. What do you expect? But it's it's when he's reconstructing the scene where an explosion was, trying to figure out what happened and what his buddy Happy was like trying to point him toward and stuff. So same idea. Again, much fancier. Yeah, taken to maybe 10 or 15 years further in the future technology, but it was kind of cool.
That I love seeing how science fiction has inspired like real science. I've read a lot of like science fiction books from like the 50s and stuff, and what used to be just fantasy, like this, they were just making stuff up practically, or very very theoretical things are now like commonplace and everyday, and it's just really cool because like as things have sped up and progressed, it's there's that line blurs so much.
Yep.
And it's very exciting.
Yeah, Jules Verne was a master of that, but there's even stuff in like stuff in Star Trek and things that it's pretty crazy.
It's really neat. I wonder how much of that is just kind of kids or young people like growing up on that stuff and then saying, you know what, I'm gonna do it. I'm gonna make that happen. And
could be. I mean, certainly I'm sure there's some inspiration stuff. There's also probably a lot where writers or whatnot are able to hear about hear things that are being worked on and kind of project out what things are going to be like.
Let's see. Oh, hey, we have some cool folk here in the chat. Aunt Pruitt says hello. Hello. Uh, let's just scrubbing through see if there's any questions or anything. Let me see. Okay, so without necessarily spoiling anything you're not supposed to talk about, what are
Okay.
you excited for coming up? Like, let's say the next
Oh.
year. Let's say the next year. We're kind of halfway through this one. So, what do you think July 2021 is going to be like? And are you excited for anything in particular? Are you hopeful for anything in particular?
Well, I'm assuming by then that we'll have the next generation of Nvidia cards. I'm excited to see what they do with that. I know there's rumors and stuff floating out there, and sometime in the next 6 months, maybe ish, would be my guess. But yeah, certainly by a year, I can't imagine we wouldn't have that. I've been personally holding off at home on getting an RTX card because I usually like to wait for the second generation, like a new technology like that,
Sure.
to kind of get the best performance for your dollar. And I've got a 1080 Ti and a 1080 and a 980 and a 1060 at home on my 4 systems. So I'm not exactly way behind, but I've been holding off on the RTX. But I'd love to get that and try out some games. I play a couple things that could benefit from RTX. So that'll be fun. And I'm curious to see how much of a boost, a lot of the rendering applications that use GPUs, so V-Ray and Octane, and the next version of Redshift will support it. It doesn't yet, but the upcoming version will support RTX.
Okay.
And I'd like to see how much of a generational improvement they have in that area, going from their first gen to second gen of that technology. What else? The coming year. SSDs are already so fast. That's, it's always nice to see those keep coming down in price as they go up in capacity and speed. I like that. Right. Someday when we don't have to worry about hard drives anymore, it'll be nice.
I am convinced. I am convinced that we will, in very soon, reach a point where there won't be a difference between like RAM and storage. It'll all just be non-volatile. It'll all be that fast. It'll all just be practically directly connected to the CPU.
Someday maybe. I think that's a lot further out. Certainly not a year, and
oh, sure,
probably a lot further than that, because when that happens, they'll have to re-architect a lot of stuff. Windows, and I guess I don't know enough about Linux and how it handles things, but I assume it's similar in that it treats memory and storage very differently. And if you suddenly don't have, if it's all just one pool at some point, I don't know. It would just require, I think, a little bit of a rejiggering, and I don't know how big of a deal that'll be. Especially for legacy applications, they'll have to do some sort of
that's true. Maybe
emulation or something. It probably will happen eventually,
yeah.
But I don't know. We'll see.
I could be in a bit of a dreamscape because I don't quite really understand how operating systems and the processing part works, and how a vague understanding of the programming of how memory works versus storage and things. So I could be kind of blurring that up a little bit.
Well, it's interesting because there's a lot more, people don't usually think about it, but there's cache memory on the processors as well. So really, for most systems right now, there's sort of 4 or 5 levels of storage, and in mostly that's only 2 layers are transparent to the user. You can see how much RAM is being used, and you can see what you actually have on your storage. But then most CPUs have 3 levels of cache in them, at least. Again, not a chip designer here, but as I understand it, usually level 1, 2, and 3 cache, and those will certainly have to be run, because the CPU actually can't. My understanding, again, at least, is the CPU has to bring stuff into the cache to actually do anything with it usually.
Okay.
Other than maybe simple copying and stuff, but if it's actually running calculations, so those layers, at least, I think will always be separate. Mm-hmm. Yeah, you might get to the point someday where everything else is just so fast that there's no need for system RAM for that temporary in-between space. That would be pretty cool.
Yeah.
But we'll see.
It'll be cool. So we have another question from the chat. This one is from Aunt Pruitt. He's asking, what are your thoughts on AMD and its pro grade cards? Seems like people are sleeping on them. He's not much interested, but they are fascinating.
Yeah, so I haven't had a chance. I think we might have gotten a sample. It might actually be that one sitting over there behind me, of one of the new. Oh goodness, what are they gonna? I'm gonna butcher the name probably now, because they've gone from being Fire Pro to Radeon Pro, and now I'm not even
Do we
sure.
get to see
I
it?
think it might
Do
still
we
be
get to
called
see it?
Radeon Pro. I don't know if I'm honestly
Oh.
not sure, but it's it's in general, in the last few years, loving AMD CPUs. AMD video cards have not been as impressive. I mean, in some ways, they don't have a feature yet that competes with Nvidia RTX, for example.
Okay.
So, like on the rendering side, there's just no way they're going to match. And I've had more weird driver issues. The few times I have tried to test them, there have been strange driver things going on and stuff. So, um, I tend not to find them as appealing,
Okay.
personally. But that is something actually, I need to find out if what the stat on that card over there is. I know we got sent something from AMD video card wise. I don't know
Okay.
exactly the details. I haven't had a chance to look into it, but I should probably test that in like SolidWorks and stuff like that.
That would be
Places where RTX doesn't matter, but the pro level of performance and, well, not so much performance, feature set, I suppose, would be the way to
Okay.
put it. It should matter. Again, in the recent couple of years, they just haven't been as good as Nvidia for those applications. But
Yeah.
well, when they come out with new stuff, we still got to test it.
Right. Right.
Someday that might
Um,
not be the case.
I am hoping that AMD has their kind of aha moment where they kind of take a bite of Nvidia like they have with Intel.
It would be cool. I have to imagine it's got to be a little bit trickier as a company to split your time and attention between two such separate markets.
Right.
Because AMD only has these because they bought ATI years and years ago.
Yeah.
And I don't know. It doesn't seem, since that happened, it doesn't seem like they've made as big a strides on the video card side as they have on the CPU side.
Right.
But I don't know if that's because it's harder to do, or it's something they're not putting as much emphasis on, or maybe just their competition has been keeping up better. Maybe Intel or Nvidia has been doing a better job of keeping up on that side of things than Intel has on the CPU, for example. So they've been able to catch up more there. I don't know.
Yeah. Yeah. Let's see. Oh, you have mention of tensor cores in Adobe. Oh, this is from Matt. Saying that it shouldn't be too far off. Their Sensei AI stuff is prime for that. And then After Effects using C4D and using Redshift renderer. I don't know. That went a little over my head. Let's see. Didn't stop trying to innovate when they were ahead. Intel really slept on their laurels since Sandy Bridge. That does seem to be the case. Like Intel kind of was like, oh, we're at the top of the mountain. We don't really have to try that hard. And then AMD really kind of, well, I would say bite at their ankles, but in my opinion, they really have come out ahead. And Intel seems to be scrambling. Let's see. So I'm curious. Is it just a matter of so with, let me see how I phrase this. We're seeing more and more like computational processes, I suppose, being written for GPU, but a lot of the software you work with is still very much CPU. It's often multi-threaded, very well multi-threaded, and CPU not bound, I guess, but is that by design? Do you think that is it the actual process that the software is doing requires a CPU, or?
I think it depends. What video cards do really well is stuff that is not terribly demanding calculations, but where you need to do a bunch of independent calculations at the same time.
Okay.
So, for example, one of the reasons that it works so
Parallel.
well with, yeah, exactly. One of the reasons it works so well with rendering, and did even before the advent of RTX and stuff, is because rendering, what we call rendering when you're talking about things like that, and the term gets used in a lot of different areas. You can do video rendering and stuff, but specifically when you're talking about like 3D rendering and in the realm of animation and movies and stuff, is ray tracing or path tracing. And so what you're doing is you're calculating where one photon of light is going, what it's bouncing off of, how it changes color as it interacts with objects or moves through translucent objects, things like that. And those rays are completely independent. So you could, if you need to calculate a couple million rays to get a whole picture of a scene, you can do all of those separately. And video cards can work on thousands of things at once. And so, you code it correctly, you can do that on the video card and get very good results that way. Whereas a CPU can work on maybe 8, 10, up to 64 or 128 things, maybe at the most on the high-end ones at a time. And it'll calculate each ray faster because it's higher clock speed. It's got more processing capabilities per core, but it can't do as many at once. So so things like that lend themselves very well to video cards. And then you end up with those types of calculations on the other side of things, a lot of types of physics simulations and things like that. If you're trying to calculate, again, it depends on the sort of thing, but some of them you have to know what happens. If you're trying to calculate the next step, you can't do that until you know what happened with the step before. So it's sequential, it's not parallel. And in those cases, it doesn't matter. You could have a million cores, but if you can only be working on one at a time because of the way the calculations behave, you're not going to get any benefit from all of those. And so a lot of, especially older software, stuff like Solidworks that's been around for a long time, the simulation aspects of that will often be using fairly old and established, sometimes decades old methods of calculating that are very much sequential like that and don't see a benefit. Or even if they're newer, depending on the sort of calculations, they might just be limited in how many threads they can use depending on what's going on. So I think you see a lot of that with more professional grade and established software that just doesn't change as frequently because what is there works. And changing stuff, you have to make sure that you're getting the exact same result. It can't be close. Rendering and stuff, you can do fudgy little tricks that just make sure the scene looks like 99% the same as something else, and nobody's going to notice when it's going by at 30 frames a second in a video or something.
Sure.
So you can get away with stuff there that you can't necessarily when you're trying to calculate, say, the stresses on a bridge that you want to build. That has to be exact. So I think there's a lot of that. Older, more legacy and more ingrained professional stuff tends to shift less quickly to newer technologies, and may just be doing calculations that just can't go in the same directions. And so that's why it is still nice to have high clock speed, lower core count CPUs around, and that is the one area that Intel still has the edge in. The last couple generations, they've still maintained the best single-threaded or very, very lightly threaded performance. So usually we still recommend them for engineering applications, and a couple of the photogrammetry ones that don't utilize cores as well.
Sure.
And I feel like I'm forgetting a couple of the things I was going to say now because I went on a long tangent. But
That's okay.
Yeah, that's kind of how it goes. So there's some stuff that can go over to the GPU. Oh, and that's what I was going to say. Is a lot of stuff's a blend, a combination, especially in photogrammetry. There's most of these programs get some benefit from the video card in certain steps, depending on what they're doing. The steps that are more well-threaded, and then the other steps, it'll fall back and just use the CPU because it needs to go faster but do less things. And then some steps are a mix of the two. So, yeah.
Oh, right on. So there was another question, but also kind of led me to think of one myself. So from Desmusin to here on Twitch, he says, is there any real ties to some of the rumors that any GPU could actually take over all the work and eliminate the need for an x86 or ARM CPU in the next 5 to 10 years? But that led me to another question as well.
I don't think so. I mean, again, some workloads will run mostly on the video card. Like if you're doing GPU-based rendering, that's primarily on the video card. But there are still some steps where the CPU is feeding data to the video card, sending the scene data to it, or calculating, like if you're doing a rendering an animation, so there's where there's multiple frames, the calculations in between each of those, figuring out what's moving, what the new positions are, where the geometry is, and then sending that off to the video card for rendering. Some of that stuff is at least currently still done on CPU. And while maybe some of that could be done on the video card, clock speeds on video cards are nowhere near as high as they are on CPUs. So you'd end up with worse performance if you did try and push those steps off to the video card instead. So I don't think it's something where video cards are going to take over and there won't be a need for a CPU at all anymore. Depending on the application, one or the other is sometimes more important, or it's a blend. Yeah, it really depends on the application and what you're doing and what stuff is going on behind the scenes as to whether CPU or GPU or a mix makes sense.
Okay. And so and the mention of ARM actually inspired one question for myself. So Apple, right, is I think it's official now. They are going to be moving to their own custom ARM chip for their hardware. Do you think that that's going to have a wider effect on the PC landscape? Do you think Windows, ARM, and all that? I know there's a version of Windows out there.
Yeah, there's a version of Windows that runs on ARM already. Honestly, I've never tested ARM stuff. I mean, I know that's what runs most of our phones and tablets and things like that. My understanding has always been that ARM gives you better performance per watt, drastically, like uses much less power, but that it doesn't, at least with most of the designs that are out there, doesn't focus on as high of absolute performance. The clock speeds aren't as high, the total calculating capability, even if it's a multi-core processor, doesn't tend to be as high. Now, that may just be because that's what the market has needed. I mean, that's what you want for tablets and phones that have to run off of relatively small batteries and last a day or longer. So you don't want a powerhouse in there that's pulling, what some of these Threadripper chips will pull, like 280 watts under heavy load, right? That would drain the battery in seconds, maybe minutes at most.
Yeah, right.
So, and it would probably burn your hand while it's at it. So my understanding is that's what ARM's been used for traditionally. I don't know enough about the architectural differences to know if it can be scaled up to be competitive with x86 if you want it to be, in terms of, again, that single threaded performance. I know you can go wide with very high core count stuff in a similar vein to video cards and GPUs, where you can have a lot of cores but at a low clock speed. That's used, I think, a lot in cloud servers and stuff. But yeah, I don't know if you can get as high of just single threaded and lightly threaded performance that way. I guess we'll find out as Apple makes that transition.
Sure.
I could certainly see it. If it does. I mean, who knows? I don't know what are the big names in ARM CPU manufacturing? Is it like
Snapdragon?
But is it Qualcomm? Is that? I think that's the model is Snapdragon, or the family.
Okay.
But I think it's Qualcomm. I'm not entirely sure. Again,
that would make
way
sense.
Outside my experience area.
Yeah.
But it would be interesting to see them come out with a desktop class CPU and motherboard. I mean, it would have to be the whole ecosystem.
Right.
And the thing you would run into, I think there are Windows. There's versions of Windows designed to run on that for tablets and stuff. And I'm pretty sure Linux can run on just about anything. But the software that runs on top of the operating system, I would assume there would have to be some translation layer there for stuff written for x86 architecture in order to run on that. So you'd probably have some penalty there. I suspect Mac or Apple, I should say, is probably going through and rewriting, or has written maybe already, a lot of their stuff native for that architecture. Okay. Which would, of course, help performance there. I don't know, but that would be something that would be, I think, a hurdle if you were to suddenly have that available as a third competitor to Intel and AMD on the CPU side. Yeah. But it would be interesting. Yeah.
I'm curious to see how things might change in the future.
Yeah.
Yeah. Is there anything um, say you had all the time that you could ever want, is there anything that you don't currently get to test that you would
Oh.
like to?
Um, hmm. I'm not sure. We test a fairly wide range of software between the four of us in labs. Um,
And yeah, not just your slice of the pie, but just
in
like
general.
yeah.
Um, hmm. Sometimes I do miss game testing, but honestly, there's so many websites out there that do that already that one more voice doing that wouldn't be a huge
William just wants to play
importance or
video
anything.
games on the clock.
Yeah, I wouldn't complain. Goodness. I don't know. That's actually a really interesting question. One of the things that affects what we decide to test is how big of a market there is for it. I mean, there could be some fascinating piece of software out there, but if there's only 50 people in the world that use it, it's not worth it to us to test normally. But that is actually something that we've sort of branched out a little bit and have a new offering. And I don't know if you guys have mentioned this on the stream in the past, but our labs consultation service. So if somebody's got a piece of software or some other workflow or use case that we're not testing right now, they can come to us, and if it's something we can test, at least we've had a couple where like it was just something that didn't make sense for us to test. We didn't have experience with that or the right hardware to test it, but if we have the right stuff, if it makes sense, and if the price works out, because we have to charge for it, unlike most of our stuff that's just free on our website, we can do specific tailored individual testing, and I've done a couple of those now, and those were certainly interesting. I think that's kind of a neat approach that we can take, where something that maybe even only a handful of people, or even something custom written that somebody's got and just wants to know how it runs on a bunch of different hardware but doesn't have access to 20 different configurations like we do. We could take that, run it on a bunch of stuff, give them results. I actually really enjoyed that sort of stuff, instead of just running the same old tests over and over again, writing another article about the same thing but trying to make it sound a little different,
Right.
so it's not just carbon copy every time. That stuff gets kind of boring. It can be interesting, like especially if I get to branch out and test hyper-threading and simultaneous multi-threading like I did recently.
Yeah.
But I like that stuff that's different, and that's a pretty cool thing. So I'm glad we've been able to start doing that, and I think it's useful.
I often get questions about audio production and digital audio DAWs, right? DAW
Yeah.
stuff, and I know that's been something we've wanted to look into, but I'm just genuinely curious, like how much of an effect the hardware could have on something like how intense is audio production that you might need a big difference in hardware configuration.
I've only dabbled a teeny bit, and mostly just in really simple stuff like recording voiceovers and doing very simple noise reduction and things like that. So I am no expert, but my understanding is the main thing with audio is that it has to be real time. So like video or rendering or whatever, you can go in, you can edit stuff. If it's a little slow on the frame rate while you're watching it and editing, it's not a huge deal. And then eventually it can take all the time it needs to calculate the final product. Audio stuff, I mean, if that's playing back at half speed because your system can't keep up, it isn't going to sound anything like normal audio. Even if it's fractions of a second off, it's not going to sound right. You're going to get pops, or you're going to get weird stuff going on. So it has to be real time all the time. And I think that's the main thing that probably people would want us to be looking at if we were testing that, is making sure that a system is snappy enough and responsive enough that it can keep up with audio in real time without latency, or with acceptable levels of latency, levels that you can't perceive. And then how much you can throw at it that way, like how many different audio channels can you have going at once and still keep that up. That's my understanding of where it goes, but it would be interesting. I'm not a musician or an audio guy really at all, and I have a fairly weird taste in music, so I don't think I would probably be the right person to be doing that sort of stuff. But that would actually be really interesting. I'd love to see the results and see like how we went about testing it. Um,
Yeah.
but it's definitely outside my own comfort and experience levels at the moment, anyway.
Uh,
Um, but yeah, very interesting.
it would just be cool to even learn a little bit more. Some folk here in the chat are mentioning things like when you have hundreds of tracks or instruments and vocals, it can load the
Yeah,
system.
totally.
Filters and compression take processing. So yeah, just part of it. Part of it's just to learn more about I suppose, the industry and what all goes into that sort of a thing.
Yeah.
Because yeah, it makes sense. Just like you would with video or even like a physics simulation or something. The more parts that you put into it, the more strength and hardware performance you're going to
Yeah.
need to make it work.
Yeah.
There's a part of me that was like, man, how hard can audio really be?
You'd be surprised. And again, yeah, it's not a huge deal maybe to be playing back a couple tracks of audio.
Right.
And I mean, like, yeah, you can. We're doing audio stuff right now. Like, there's no perceivable latency when I'm hearing you talk or anything. I mean, there's the video stuff, like the transmission over the internet, but it sounds okay. But suddenly, if you're doing, a whole orchestra. I mean, I guess I have no idea. I'm probably going to mess some stuff up. But if you had a bunch of different instruments all mic'd and singers and background stuff going on, and then you also a lot of times want to apply effects to some of that. Maybe you want to bring volumes up or down, or adjust waveforms, or add reverb. All those sorts of things add processing power, and you have to be able to keep doing that in real time, constantly, without hiccups. So, yeah, it's definitely an interesting area, and it's also an area I'm under the impression that a lot of folks use Macs for, but that PC stuff does exist for, and
Right.
Yeah, it would certainly be interesting to dabble in someday.
Have you had anything lately? And let's go back to maybe November of last year, because I think that was a major CPU launch at that point. Anything kind of surprising or something? Anything that turned out different than you expected?
It's a good question. Let's see. Well, so the CPU launches, Ryzen came out, I think, a little earlier than that, a little further back in the fall last year, the latest Ryzen stuff. Threadripper, I think, was around then, the 3rd gen Threadripper, and then
Okay.
I think it was into maybe this year, even before the very latest, the 3990 came out. The 10th gen refresh was just recently.
Mm-hmm.
I think unexpected. I was surprised that they came out with a 64-core Threadripper, I guess, to some degree, like when that they were able to go that far on consumer or workstation grade stuff, not server.
Sure.
That was impressive, and I'm glad they did. It's a tremendous processor, but the performance it offers is in line with what one would expect given the 24 and 32 that preceded it.
Yeah, because 64 core definitely has a Xeon feel to it.
Yeah, I mean,
that
it's
super higher end, like almost server grade.
Yeah. When the Threadripper stuff is akin to AMD's EPYC. It's in the same architecture under the hood family, and that stuff's got high core count. That's kind of their version of Xeons.
Right.
But yeah, it was cool that they were able to bring that down to something that could exist on a workstation board. And I mean, it's hot, 280 watt TDP, so it's toasty, but it's doable. And so that's really cool, and that's had a huge performance impact in a lot of areas. Nothing surprising that I can think of right off the bat, I guess. Yeah, I tend not to be super surprised by things. I mean, you can usually get a good idea of where performance is going to be if you know, like, a 10-core version of the same, based on the same technology, an 8-core exists already, is coming out. Well, okay, it's going to be at most 25% faster, and more likely probably in the like 5 to 15% faster range. And sure enough, there it is. So it's not a lot surprises me, I guess, but Yeah, biggest thing probably would just be how quickly AMD caught up and surpassed Intel in a lot of areas. Again, they haven't surpassed everywhere. The single-threaded performance is still Intel's holding on to a lead, but yeah, that's.
Yeah.
But again, not a surprise. I saw it happen 20 years ago, so
Right.
history repeats itself.
Yeah. Let's see. Man, there's some. Let's see. I got some talk. Good stuff going on in chat. Amongst there's like talk about local accounts versus online stuff. What antivirus, anti-malware do you prefer for performance-critical applications? This is always a good
I've
question.
honestly just used what's built into Windows for years and years now. Back in the day, I used to use AVG or Avast years and years ago. But with Windows, it was either 7 or 8, somewhere in there when they came out with Microsoft Defender or Windows Defender, whatever they called it back in the day. I switched over to that. And then now I'm not even sure they use that name anymore, but it's just the stuff that's built into Windows seems to be sufficient. Honestly, the far bigger thing with virus and malware stuff is just being careful what you do. The only times I've actually ended up getting a virus were when I was going somewhere and I'm like, this seems like a really suspicious website. I probably shouldn't download this, but I want to give this tool or utility, whatever it's supposed to be, a try.
Yeah.
Nope, sure enough, that was virus written. And so
Same.
being careful about what you're doing. Don't click on links in emails from people you don't trust, or if they look suspicious, even if it's someone that you know, because stuff like that can be faked. Don't intentionally go to suspicious websites. Don't download stuff from suspicious places. Have like a ad blocker if you are going to go to places like that, because some stuff can come up through flash ads, I think, and things.
Oh, yeah.
And then if you are going to go do something intentionally silly like that, back your system up first so you can restore it. And honestly, these days, there's actually some pretty cool stuff in Windows where you can just have a virtual machine very easily set up and go do that in the virtual machine. And then that way, if something happens, you just blow it away and make a new one. I think that was, I don't think it's the latest 2004 release. I think it was 1909. That version of Windows, I believe, is where they brought in a real easy way to make just a whole fully functional Windows 10 virtual machine right inside of Windows 10 Pro. I don't know if it's available in the home version, but in the Pro version at least. And set that up if you're going to do stupid stuff, because you're not gonna feel near as bad if that goes sideways as if your whole Windows install does. So.
Okay, one last question.
Okay.
I'm gonna twist this one a little bit because I want to kind of hit on a larger topic from it. But Nightlife66 on Twitch, he says, "Whoops, where'd it go? What do you think about things like GeForce Now or the Shadow Blade trying to move everything into the cloud? Will PCs become more of just clients to big server farms, and people will pay places like Nvidia or AMD for server time?" So I suppose the bigger question there is like, is the cloud going to kill your home PC?
I think for some stuff that will happen probably. I mean, I don't like it. I like owning my own hardware, having control over what's in it, how it's going to perform, not having to depend on somebody else's server or how my internet connection is behaving that particular day. And I'm privileged, I know, to have, like, I think we have gigabit here at the office now. I've had gigabit at home for a few years, so I don't normally have to think about things like that. But I'd rather not depend on that. I'd rather have the stuff local, personally. And I think there are certainly, even with gigabit, that's about 80 or 100 megabytes per second that you're actually going to sustain through there if your computer and your internet connection and the server on the other end can handle it all.
Right.
But if you're doing like video editing or some of that sort of stuff, can actually use a lot higher bandwidth than that. So I think there's definitely areas that I think, at least for a long time, will stay local, or at least the high end will. You might be able to do some stuff, like you can actually go in and edit YouTube videos. Once you've uploaded them, you can go in and trim them and do things like that. But then you also have to wait minutes or hours for it to process on their end, and you can't go back and edit it once it's been edited, or while it's processing you can't change it. So there's a lot of limitations to doing stuff like that. And games, for example, one of the big things with games is latency, right? Like, especially if it's depends, strategy games or something, maybe it's not quite as sensitive, but if it's a first person shooter or anything with a lot of action going on, racing games, if you're adding an additional 100 milliseconds of latency for transmission to their server doing the calculations, transmission back to you, rendering it, you're gonna not have nearly as fluid and good an experience shooting your enemy or driving and missing a collision, things like that, just because of that extra latency, even if everything else looked as good and felt as good. So I think some stuff will stay local for a long time, or we'll go to a split where some people can do it one way, some do it another, depending on what they what they can afford. There will be people that can't afford local hardware, and so maybe for them a subscription service online or something will end up making more sense.
Sure.
So I think we'll see things move around a little bit. It all just depends on the specific application. I personally prefer to keep everything as local as possible, but I'm also still the guy that has a big DVD collection and a lot of video files and music stuff locally on my home network, even when Netflix and Disney Plus and all those exist. So I use both, is what I'm saying, I guess. But I like having the ownership personally.
Well, I have to agree, especially when you brought up the internet speeds. 800 to or 8. We're talking hundreds of megabytes when my laptop SSD is doing 3 gigabytes a second. So.
Yep.
All right. Well, that does bring us to a little over our hour.
Cool.
Is there anything else you'd like to say? Anything you want to shout out or read your latest article?
Not particularly.
Like that? Follow social media.
Yeah, it's I like it when people come and interact on our Facebook and Twitter and stuff, so feel free to do that. I'm relatively active on there, so if you have questions or whatnot, feel free to hit me up that way, or in the comments on our articles and stuff is great too. It was fun.
Cool. Well, thank you very much, William, for taking a bit of time out of your day and helping answer questions and have a bit of a conversation with our audience here.
Yeah.
And thank you as well to the audience for joining us a little bit after lunch. I hope you got some value out of it. I hope you join us next time. We do this every Wednesday and Friday at 1 p.m. Wednesdays, we bring in outside industry expert to kind of do something similar, talk about their particular area of expertise, and answer some questions, give a little insight into their thing. And then on Fridays, we have a member of our labs team, like William here, basically do the same thing, kind of talk about what they do, how they do it, and take questions from you guys. So mark your calendars, Wednesdays, Fridays, 1 p.m., YouTube, Twitch, Facebook, and Twitter. And I think that'll do it.
Cool.
See ya.
See ya.